Hello, and welcome to the eTech podcast with me, your host, Ryan Morn. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts, as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. So today's podcast is an interview, and this is one I've been trying to organise for a long time now. It's a guy who I've known for a while. I've seen him present a number of times at very specific industry conferences. It's Uwes Müller from Volvo. He's been involved with a really fascinating programme to do with automation and electrification of off-highway machinery, which is an absolutely huge sector, very rarely gets talked about in the mainstream press. So I asked Uwes to come along, do a podcast, and really talk about the exciting work that they've been doing in the off-highway sector. So without further ado, we'll get on with today's podcast. So on today's show, we've got Uwes Müller from Volvo, and he's going to talk to us about the really exciting work that they've been doing in the field of autonomous and electrified off-highway machinery, which is an absolutely massive area. And we've crossed paths at conferences and things in the past, and I've always been absolutely fascinated to hear the story and the journey that Volvo have been through on the way to more autonomous and electrified vehicles. So, Uwe, thank you very much for agreeing to do the show and join us today.
Sure, thanks for the invite.
I was just wondering if you could just kind of basically tell us a bit about yourself and what you do and your role and your background.
Sure. So my name is Uwes Müller, working at Volvo Construction Equipment since 12, 13 years meanwhile. Started in the company as a test engineer for excavators and wheel loaders. Started working for Volvo in Germany. Been based there roughly 10 years, and then I moved to Sweden, where I've been working as project manager in the advanced engineering area. And now, beginning of this year, I just moved over to the commercial side. So now I'm sitting officially in sales as program manager, commercial pilots. Really my new job, so to say, is bringing all the technologies that we have been developing so far, specifically the new stuff, to the market together with our customers.
Okay, fantastic. And that is the autonomous projects and this kind of program. So you're actually... This is now market launch phase of this kind of technology.
Exactly. So it has really been, so far it has been prototypes, advanced engineering work, but now we're really moving that over towards the industrialization phase. We really want to start with some customer pilots, but also we're really in a proper commercial setup, and from there really want to scale the complete solution towards the market.
Wow. So could you just tell us, so the your autonomous mine equipment, Can you give us the history on that and the research that you've done in that field?
Absolutely. So the autonomous or electric quarry project that we did in Sweden, we started that in 2015 officially. The project was kicked off together with one of our biggest customers here in Sweden, Skanska, and it was also heavily supported by the Swedish Energy Agency. And we had support from two universities, Linköping and Mälardalen here in Sweden. And there really the goal was to electrify a complete work step in a quarry as much as possible. So it was really initially all about electrification, but through the project and already in the preparation of the project, we realized that in some areas automation is really an enabler for electrification. And what was also good there from our side, we have been working both on electrification of various machines, but also automation of various machines. So we had quite some knowledge there, specifically on the electrification side. We also share knowledge in the Volvo group with our colleagues from buses and trucks. Buses has been out many years with electrified solutions, so we really had a solid foundation to build on, and then we really sat down with the customer, looked at their site, looked at their process, and really came up with a complete new solution where we had different versions of electrification and partly also automation.
Wow. So actually, there you go. I've learned something new straight away there. I didn't know that this all started as an electrification program. So I don't know why, but I thought it started as an automation program. So that's fascinating. So actually, the initial goal started as electrification. I mean, to people who haven't seen it, you really came up with something completely different in terms of a mine site concept.
Absolutely. So what we really did, we looked at the process today, and in easy words, it's today more or less they blast the material, then they go in with an excavator, 70-ton big excavator. From there, they load the material directly into a mobile crusher. They crush the material. From there, they rehandle it with a big diesel-driven wheel loader that loads it down on diesel-driven rigid dump trucks that transport it further to the next production step in the quarry, so to say. So that was where we were coming from. So here we really looked at electrification, all those diesel solutions, which is an excavator, a crusher, a wheel loader, and a transport solution. Excavator crusher was pretty straightforward. Together with the customer, we decided to put those two machines both on a cable, connect them straight to the grid. The wheel loader was a little bit more complicated. That machine is moving around a lot. It's doing different tasks, so putting it on a cable is tricky. Also, full battery electric on a machine that size is also tricky with battery solutions today. So there we decided to go for a hybrid machine. And then when we looked at the transport stage, it starting from big rigid dump trucks. Well, a first analysis showed that for the machine's size they have today with 40 tons payload, we would roughly need 15 tons of battery per machine.
15 tons.
Really feasible from 15 tons of batteries, exactly. Yeah. Which is not really feasible from an efficiency perspective because you carry that additional weight continuously around with you, and not even talking about the cost for those batteries, so to say. But also on top of that, which was also an interesting topic, if you would build those machines, also the infrastructure you would need to charge those machines, that those chargers would create quite some huge power peaks on the grid side that would require quite some investment on the grid infrastructure side, which is even increasing cost more. Yeah. So then the first thought for us was for sure, let's maybe go for smaller machines. Well, we also looked in the Volvo group, maybe we take some Volvo trucks, off-road trucks, whatever. We take some more machines, but smaller ones, so that we get down in battery size. The issue with that then is you still have quite some capacity that you carry around, and on the other side also you need more machines to keep the production. With more machines you need more operators, which is then also again increasing costs, which then makes your system not really commercially viable. And that was really for us the point where we said, wait a second, maybe we should really go to such small machines that we can handle the batteries in a reasonable manner. But to do that, we also need to automate to make it really commercially viable. And that's why we came up with our solution, which is like a full autonomous battery electric 15-ton load capacity hauler compared to a 40-ton diesel-driven rigid dump truck that they had before, so to say.
And they're fully automated. There's no cab, there's no driver. They just...
No, there's...
Is it a central control system on the site, or how does that work?
Yeah, correct. And that also comes with several benefits. So it's a fully automated machine. It has been designed like that from the beginning. So we really designed a machine to be electric and autonomous from the beginning. With that, we also have a site control station at the site where we have one guy sitting that controls the fleet, so to say. But there was also a lot of other benefits with it. When we looked at the concept, we also said, like, in the process, you have like one shift where the excavator feeds the crusher. The crusher at the end has a conveyor belt where the material comes out, and today it's just falling on the ground. To in the next minute, a wheel loader comes and lifts it up again to load it on a truck. We said, can't we just use that? The material is already at the height. Can't we use that somehow? And then we said, okay, but we developed a new machine. We don't have a cab. Can't we design the machines in a way that we have a continuous flow of machines that drives straight under the conveyor belt and takes the material directly from the crusher? But you need to have something that is continuously, because you can't swap machines, because then the crusher is always running. You always have a material flow that would fall in between the machines. That would mess up your system. So you need to have a constant flow. And that's why we designed the machines in a way that they can overlap each other. And with that, you have a continuous flow of machines that you can drive under the crusher. And with that, you delete even a complete work step. So here really automation with electrification, machine design, killed in principle a complete work step, and that's really efficiency in a process.
So you're like actually completely reinventing the kind of mining process from the bottom up.
And that was really the idea, to really look at it from an overall process level and not just trying to exchange an existing machine with a new machine. And that was really also the mindset we had together with Skanska, the customer. And that was really so great in this project, that we worked directly together with the customer from the beginning. Because we have kind of the machine and the technology knowledge, but the customer knows the process. He knows how they run their site. They know that much better than us. And if you put those two competences together, you can reach much, much more than just designing a machine and exchanging an existing one with a new one.
And do you feel like that approach of designing the machine from the ground up to be autonomous and be electrified, that brought advantages over converting an existing product?
Absolutely. I think you can't compare this machine, which has been designed from the beginning to be electrified and autonomous, with anything else where you take a conventional machine and try to automate it afterwards, or exchange an existing machine from a diesel engine towards a battery and with an electric drivetrain. So it's completely different. And it's also the machines as such. When we again then thought at the process, we realized we have a complete repetitive process where we have several machines running in a cycle. That's where we said, but we can plan that, we can schedule it. Let's do that in a way to really also use the batteries in a more efficient way, to have some continuous charging, so to say. And with continuous charging, I mean that more or less every machine has been charged once every cycle, and it just got exactly that amount of energy it needs for one cycle. With that, you kind of distribute the grid power over time, because you always have one machine in charging while the others are running. That machine goes out, the next one comes in. So you have kind of like a continuous charging of a fleet of machines, which limits your infrastructure cost. And on the other side, you also can cycle the batteries on a quite low SOC level, which is at the same time then even increasing your battery life a little bit. So it's really that system thinking, which is coming from machine design, but also that process approach that really allows you to design things completely different and get much, much more benefits.
Wow. So, you're going right deep down into the fundamentals of the usage of the machine, the design of the machine, thinking about things like battery life preservation. That's very, you basically couldn't have, do you think you could have learned that any other way than by actually running a site like that for a number of years, or it's not possible to...
I think you have to do that. I think we for sure started, before we started this project, we had the first machine like that we built also together with a student project in Sweden, where we just had the idea of a machine like that. So that time we built a kind of machine like that just with existing technologies that you have. So we bought some standard axles from a supplier, we bought a complete electric drivetrain system with some batteries. And it was mainly students that really did the base design with some support from engineers. They put the machine together, and then we really tested, okay, can we control the machine like that? That was really the next thing. Does the machine as such work? Yes. Can we control it? Yes, that worked as well. And then really we said, okay, we have this project ongoing. This could be a solution here. Let's really do the next leap. So we kind of redesigned the complete machine. We kept the principle, but then we really brought in a complete drivetrain system from the Volvo group, where we shared a lot of things with our colleagues from buses and trucks that already had that in serial production. So we really had a fantastic base to build upon, together with our ideas on machine design. And then with Skanska, we really worked on the automation system. How should that work? How should the process look like? And that really evolved. And then applying that finally at the customer side in a real operation, that tells you much, much more than just running something on a test track or on a bench test.
Yeah, I've got loads of questions actually. So, but to kind of, we'll keep on the machine to start with. So the first thing that springs to mind in terms of the site and for me anyway, running those machines like that is it how flexible is it? Like, is it easy to change the working patterns of those machines and what they're doing, or are you kind of locked in? And how much flexibility do you have through that system now?
A little bit, yes, it is flexible, and no, it's not flexible, you could say. As we are running quite some parts on a pre-programmed GPS track, that for sure requires some preparation to record it, to tune it, to set up in the system. But on the other side, if you have learned that, if you know the process, that's also doable in a reasonable time frame. At the other side, we also mix that fixed GPS pre-programmed track with some flexible parts of it. Because what we always had, we were always dumping at the same spot. The chargers were always on the same spot, so that track from the dump spot to the charger and then down into the pit, that was always fixed. So there's no reason why that needs to be flexible. And that's also good for the customer, because he can really long-term plan his site and how they want to operate. Then if you are down in the pit, you had different loading spots because we were loading the machine, as said, directly from the crusher, but also partly from a stockpile with the wheel loader. And that's where we said, okay, with the crusher, we always have the GPS position of the crusher, so we just follow that. They usually move that machine once per shift, and then you just adjust that last 20, 30 meters of the GPS track, and that you just recalculate once the machine is replaced. And with the wheel loader, it's a little bit different because he wants to have the machine wherever he's picking the material from. So there we said, okay, we're going to have a cue point, more or less when the machines get down in the pit. So there it's fixed programmed, but from there we define an area which is kind of open and free, and that's what the customer has to secure. And from there, so to say, we can then generate free-floating kind of GPS paths wherever the wheel loader wants the machine. So the wheel loader operator, he had an interface. He said, I want the machine here. That means he placed this machine, he pushed the button on a kind of a tablet, and then the system takes the GPS position really with plus minus 2 centimeters off the bucket, sends that to the system generates a route, and the machine knows exactly where to drive. And that's that accurate. You could place the wheel loader, lift the bucket, push the button, you send then the position, and you request the machine. That machine drives exactly under the bucket.
Wow.
And that works perfectly fine.
Brilliant. So your software is advanced enough to be generating the routes with you're not having to manually trace out these routes. It's just working out the best way to do it.
In a predefined area, absolutely.
Right.
You need for sure. You need to tell the system that in this area you can put out the route. That's for sure. And then always, once we generate the route, it's always the driver in the wheel loader, so to say. He look at the route on the display. Does that look feasible? If yes, he just approves it, and then it's fine. Then it's in the system. So in a predefined area, you could really do that, and that was one of the biggest things that the wheel loader operators liked, and where we had our biggest concern. How will that be like humans working with partly automated systems, and how will they react to that? But they really liked it because it puts the humans into the control. It was the wheel loader operator. He said, I want the machine here. So he first tells the system, here is where I want the machine. And he actively always has to request the machine to approach him. So he always asks for a machine, he loads it, and when he has loaded it and says, I'm done, he sends it actively away.
Okay.
So the machine always gets exactly where he wants it, when he wants it, and the machine leaves when he wants it. And that's usually things that today with human operators, that's done with sometimes with radio communication, which is already advanced. Usually it's the horn in the machine.
Yeah, tooting the horns. Yeah, you see that a lot on construction sites. Yeah, so there's a noise benefit as well. No more horn tooting. No. What do you have for sensors then on the machine? Because one of the criticisms sometimes people say about the autonomous systems is either you have to have lots of really expensive and quite sensitive sensors, but I mean the environment you're operating in there is like super harsh, and you've got all sorts of issues with black spots for the GPS and things like that. What did you must have had quite an advanced sensor suite on the machines?
Yeah, it was kind of a mixed system, and also from the beginning we said that safety is always first. So the first thing we did was really put people in control. So we had a completely independent of all other systems, separate radio-controlled emergency stop system that every of the autonomous machines was connected to. There was an emergency button in the excavator, in the wheel loader, and in the site control room. Whenever you push that button, all machines were standing immediately. That was really the first thing. And that system was also kind of fail-safe, that if one of the machines loses connection to that system, they stand immediately. So that's first really putting people into control. Yeah. On top of that, so to say, we had done that what we call fleet and traffic management system, that the system continuously knows where all the machines are, the autonomous ones as well as the manual operated ones. So with that, we can do kind of like a geofencing. So that could already also, on top of that, in autonomous control, stop machines from running into each other or running into a manual operated machine. So that means once an autonomous machine approaches a manual driven machine, it reduces speed until it gets too close where it even completely stops. Right. Then you could say, okay, you can't, well, like you say, you can have a black spot on the GPS or whatever, so the machine doesn't really know where it is, so you get the wrong signal. So you can't 100% maybe so far today trust the GPS signal. So that's why we said on top of that, the machine continuously monitors where am I compared to where I should be. If there's a too big difference, so if the machine is too far off from the initial planned track, the machine stops. Right. Or if you get the system realizes that the machine makes a jump in position, that's kind of unreasonable. That if it moves 20 meters within a second, then also the system sees, okay, there's something wrong with my position. I don't really know where I am. I stop.
Right.
And then on top of all those systems, we also had an optical detection system on the machines, which was LiDAR and radar based, so that the machines could also see if there was something in the way, they could stop on top. So we had like 4 or 5 levels on safety features, because really safety is always first.
Wow. Okay. And the LiDAR and the radar would be actually in that case almost a backup to the other kind of positional systems. Is that right?
In this case, yes, it was really, because we only use them for optical detection. So you could really say, as it is an autonomous system, you don't really have people involved directly. You could say it's not even for safety, it's more for uptime, so to say. And it was really an on-top thing. And we have not, in this case, used them for navigation, because navigation was purely based on GPS.
Right. And it just seems like, I mean, I guess to start as an electrification program, but then end up as a whole mine site redesign. There are some pretty big challenges, big problems in the mining industry to do with their efficiency and the energy consumption with the fuel, but then also people. It's a huge issue in mining, the availability of skilled operators to drive the machines. So, was that kind of was that in the thinking from the beginning, trying to help fix that problem, or did that come as
yes and no? I think yes and no. If we talk about operators, I think that the thinking was more that the people you have should add more value to your process.
Right.
Because if you sit in a rigid and you drive in a small circle over and over the whole day, you're not adding too much value, so to say. And also, like most of those operators say, it gets a bit boring after a time, so to say.
Yeah.
So let's really put the people there where they can create value for the production process, so to say. That was also kind of a thinking. So we don't necessarily see that automation will kill too much jobs initially, but it will create different jobs and change jobs,
right,
so to say. And that's also something that the industry needs to learn, and that I think was also a big learning for Skanska, because they need to understand what is the workforce of the future they need.
Yeah, okay.
Same as it for us.
And I guess it moves a lot of the people out of areas where they could potentially, because mining sites and construction sites are notoriously dangerous places to work. So
absolutely.
Puts the people away from...
It's also a safety improvement.
Yeah,
exactly.
Yeah. So maybe a big question here. There's a lot of change there in, changing a lot of things all at once. Some manufacturers have quite a high... Let's say they're very invested in their traditional products, and the concept of designing a new machine, which could make, you could be making products currently made obsolete in the future. So was there a lot of resistance within Volvo to do that, in terms of making such a radical departure from standard machinery that the company makes today?
I'd say not at all. I think for us it's also a chance to learn, because I think developing an autonomous solution based on a machine that's designed to be autonomous is much easier to automate something that's designed to be manual driven.
Yeah.
But on the other side, with that you can accelerate much more. But everything we develop here is also allowing us to maybe in the next step then also automate manual driven machines that you can then set up in a combined area, because we also see that there will for sure be tasks that we will automate in the future, but also tasks that where we clearly need operators. And then there will be a need that you have also those machines that will be both automated and manual driven, depending on the process, so to say. So that's also helping us to accelerate and develop even further, so to say. So for us, it's more an addition to our current portfolio than that we have like some internal cannibalism on different products, so to say.
Right. Okay. Really interesting. And then in terms of the original objective with electrifying the site, what are the kind of headlines there in terms of the savings in terms of CO2 and fuel and efficiency improvements? What did you manage to achieve with this system?
That was pretty nice. So we initially had, talking about electrification, going away from the diesel for sure. One of the main goals is with that naturally CO2 reduction. So we initially had the goal that we thought maybe if everything goes really well, we can reach up to 95% of CO2 reduction. That all sets, that's for sure only valid if the energy that you put into the system is kind of green and CO2 neutral energy. There, being in Sweden, it's kind of one of the nicer places to be because the energy mix in general in Sweden is already pretty clean. And then we were working with Skanska that even has an internal rule that they only purchase clean energies for all their sites.
Yeah.
So that was kind of a checkbox, which is needed to reach those high numbers. And then what we did over the a little bit more than 12 weeks that we were really running there in the site, we did the comparison and the measurements, and we realized that really if the complete system is up and running and you compare it against the diesel version, you could even save up to 98% of CO2, which is pretty tremendous.
98% CO2 reduction. That's phenomenal. That really is. Can I in the off-highway space, so mining sector, is there a strong pull? So in terms of, we all know passenger cars, there's the CO2 legislation from the government, from Europe, and in the truck sector that's just been introduced. In the off-highway side, what is the driver in terms of the CO2 reduction?
I think it's a general. It's more and more demands for less CO2 emissions. It's partly our customers, so to say, themselves that are setting higher goals on themselves to reduce their carbon footprint. That's one thing. But also for if you have big infrastructure projects, for example, you see more and more demands from the projects themselves to reduce emissions already during the project. And then if you look for maybe mining or quarries in the future, we also see that our customers get more and more strict kind of demands from the legal side if they want to have new, if they want to start up new sites, if they want to get new commissions for that. So also there, it's continuously increasing demands. And then if you, for example, look into mining, underground, an obvious part underground is for sure, if you have diesel emissions, a huge cost in underground mining is ventilation.
Yeah.
So this is naturally, it's a simple, an easy business case, but at the same time also you see that specifically with diesel particulates and the healthy point with people working also underground with all those exhausts that we need to do something and legal demands are growing. So I would say it's pretty much the same than on road. In some areas, even more a demand for less and less emissions in general, if it's CO2 or diesel particulate or whatever.
Right.
So we should do something for our planet, all of us, I think.
Yeah, and one of the things that often comes up in the heavy duty sector, because obviously CO2 directly correlates to fuel consumption, and fuel is a big input cost of these companies. So, do you think the electrified autonomous site delivers a kind of commercial return as well in terms of the operational costs, given that I'm not sure, there will be some extra investments, but some of the machinery might even be more cost effective, I guess, than the big machines?
Initially, absolutely. And we see that right now, for sure, we had prototype costs, and that's not even something you can compare. Yeah. That's obvious. But on the other side, we see that long-term wise, once those products get industrialized, you have the right production numbers that you also can scale things. We are totally convinced that systems like that will also have a commercial benefit for the customer. That's without a doubt.
Wow. Okay. So that's really where the strong market pull starts where you've got the positive environmental impact, which is what everyone wants, but then also where there's a financial there's no disincentive basically. So even cost neutral is good, but if it's cost beneficial, then that's going to be like opening the floodgates.
Exactly. But as with all technology developments, I think you need some people that are ready to be first and to initially maybe pay a little bit more to get it going. But once you start scaling, you will also see the cost benefits. Right. And on the other side, it's also, I personally believe that the ones that are early on, they will be prepared when the systems are really available and on the cost level where they should be, so they can just apply the technologies, while others will have a hard day to learn what that really means for them. So it will just take them a little bit more time. And then it's also a huge advantage if you have been one of the first. Yeah.
So the sort of early adopter advantage. Is there,
exactly.
Do you think, mining kind of context, quarrying context, obviously that's really important. We all rely on mined and quarried products for, civil houses and engineering and everything. But do you see an application for this in construction sites as well? Is that something that's in the pathway in terms of built, could you imagine a built site?
I think we see many different opportunities. If you look only for an autonomous transport, I think long-term wise it will make sense wherever you have a kind of repetitive, little bit longer-term transport need. That can for sure also be big infrastructure projects. If you build a big new highway somewhere or a huge runway for a new airport or whatever, where you have to move really a lot of material over quite some time, for sure something that could be applicable.
Right.
But then also we see applications in industrial material handling, like timber handling in big sawmills. Specifically here, as we are based in Sweden, we have a huge forest industry here. That's clearly an opportunity that we see, but also in other industrial applications, wherever you have kind of a repetitive transport. Maybe think about a big steel mill where they have a lot of transport ongoing, things like that. So we see a lot of opportunities.
And I guess one of the things people often say is, oh, well, it's all fine and well, but it's a long way off. It's 10 years, 15 years away. But given what you've done and what you are now doing, I guess your view might be it's a bit closer to being something that people could realize. So what's your view in terms of market adoption? How long is it going to take to start seeing these things be deployed?
I would say, if you ask me, my personal wish would be that in 10 years, we're going to have a hard life counting the sites that are already automated. That should really be the goal. But we also need to be realistic. We are still working with prototypes, but we really want to now move into the industrialization phase. So I believe that we will see some first pilots here and there really in less than 1.5 years from now.
Oh, wow.
Some first strides will really move into a commercial setup, so to say. And then we maybe do another design loop, a design iteration, so that we really start seeing scale-up effects in, I would say, 3-4 years from now, definitely.
Wow. So kind of faster than the on-highway, actually, because there's no legislative barriers to overcome with off-highway.
I think legislation is also something that we need to understand a little bit, because many of our legislative boundaries, so to say, that we have today are not necessarily written for an automated system. Many things is kind of described and legislated around an operator. And that's also something that we, together with our customers, the industry, but also the ones that set the legislation boundaries, need to understand and learn and develop now in the coming years to really set those boundaries in a proper way. One advantage for sure we have in this industry, like in quarries or so, that we kind of have closed environments if we want to, which makes it probably a little bit easier for us to apply something compared to if you run a car somewhere in open traffic.
Yeah.
That's for sure an advantage we have, but still that's also something where we all need to work together. That's nothing that we as an OEM can solve ourselves or the customer. That's really where everybody needs to work together. And as we all know, usually creating new standards and things takes time, like development. So it's not only that development that needs to accelerate, it's also those legislative parts that need to speed up a bit. Absolutely. Because otherwise we might have the technology available, but we are not allowed to apply it.
Yeah.
And that would be a shame.
So you mentioned that because Volvo is active in trucks and buses and things for the powertrain, you were able to draw on that group expertise. Was it the same kind of story with the autonomous systems? Is there crossover to what they're doing in the bus and the truck business, or was it very sort of bespoke to the mining application?
No, I think also there we have a strong collaboration, but I think there it's not that in the Volvo group you could say that one part is much more advanced than the others. I think that's really a joint development that we have ongoing in all areas. So we have been out now with this. Our colleagues from trucks showed already quite a while ago a first autonomous truck that was running in an underground mine. They have now also a project ongoing, which we have communicated, where we have automated also a big limestone quarry with trucks running autonomously, quite a long transport, even in a tunnel in Norway. Then we have seen our newest piece of autonomy called Vera, which is like an autonomous tractor. Then our colleagues at buses are also working on autonomy, and all that learnings that we do there, that we share across the group. So it's all kind of based on the basic principles. I like to say that the fun thing in the Volvo group is that we have a huge Lego box where you can just pick out the pieces we need for our products and then just put something fantastically new together.
And it always strikes me that you have quite a clear kind of vision in terms of developing new technologies, so trying to push the boundaries forwards, whereas some others, heavy duty industry is not necessarily known for innovation, but that seems to be kind of pushing the boundaries seems to be something that you guys really enjoy doing.
And it's one of our clear goals. We want to be leading in innovation, and if you want to do that, you need to challenge yourself continuously and as hard as you can. So it's kind of in our DNA, I would say.
Yeah, I can't remember, and it's one of my favourite quotes. So I can try and work out who said it. But was it you that said in a conference about replacing elephants with ants, or was that from one of your colleagues?
That's it wasn't me that invented that statement. It was one of my colleagues that said that initially. But I like really the concept that specifically when they talk about automation, we see a huge opportunity that in the past machines got bigger and bigger and bigger in our environment, and usually the main driver was always operator costs. So you want to reduce operator costs, so that's why you build bigger machines. And that has, I think, in some areas that went to a point where the machines are so big that you can't really handle them anymore. All components are quite expensive. Transport is a huge issue. And that's why we said, really, what if we turn it around? If automation allows us to go smaller? And that was really where that let's go from elephants to ants came up with, so to say. And that's something we believe in. And that's also something you see sometimes on other sites. Like look at all those automated grass clippers that you see running around. They're also not bigger than the ones before. They usually get smaller. Or automated vacuum cleaners that you have at home. It's like there's many applications where you see this trend, so to say. So yeah. I think it's definitely valid also for our industry.
Okay, yeah, I hadn't even really thought about that. They're two really neat examples where obviously, if you're cutting the lawn yourself, you want the biggest lawnmower possible, so it takes the least amount of time. Whereas if you're not involved in the process, the small little Robo mower goes off and does it by itself and takes as long as it takes to do it. Yeah, no, I absolutely love that phrase, and I have to confess I use it a lot, but I do always credit you guys with it. But replacing elephants with ants, you can see that in so many different applications where the size of the vehicle and machine has grown to around utilizing the operator or the driver. Whereas if you remove that out, you completely change the machine design, vehicle design, but then also the economics of manufacture, because these large machines are very, very expensive to build in the kind of numbers that we build them relative. If you looked at the cost of a big rigid truck compared to the cost of a on-highway truck, they're kind of absolutely factors different, aren't they? Yeah.
I can't agree more. So that's really the scaling factor gets much, much bigger if you have smaller and more machines.
The sort of inverse exponential cost curve or something. There's probably some clever economics term for it that I don't know. So what's next for you now at Volvo? Where are you going to take this?
Yeah, I think if we want to stick maybe to that autonomous transport solution, because it combines more or less all the new technologies. It's automated, it's connected, so also that soft offer side potential softwares that support you. You have much more information that you can use in your process, and that's also something that we see that you kind of more or less get for free if you automate. You have so much more data that you already have connected, which is just normal. Then you have the electrification on top of it. So that's really something where you can combine all those technologies. So for me personally, the next step is really together with all my colleagues, both in sales and aftermarket, but also in technology and operations, the ones that build the machines, to really get that product to an industrialized system and get it out to our customers.
Right.
As soon as possible.
Okay. Easy. That's a 5-minute job, obviously. So basically launching the electrified autonomous product into the market in a big way. And is it going to be? Europe is that going to come in Europe? Do you think first, or where do you think that will take?
It depends. I think needs are for sure. There's interest around the globe in different applications. It really depends which segment you talk, in which part of the world you end up sometimes. Naturally, for sure, as our development hub for this is now based in Sweden, I guess we start spreading it from here a bit. But I also believe that in a reasonable time frame, we have to spread it across the world because we need to be there where the customer needs it. It doesn't help us to just stay in a market that's convenient for us. That's not necessarily always there where the customer needs it.
Yeah.
So I see that this will spread. It will for sure not be globally available from the beginning. It will be dedicated markets depending on application and segment. But we will naturally start spreading from Sweden, you could say. But we have to spread it across the globe.
I think it's fascinating for me that really the sort of passenger car, autonomous passenger cars get all the headlines. There's barely a day goes by without something about autonomous passenger cars being in the news. But it's very much seen as a sort of way off future technology. And yet here you guys are with a commercially viable autonomous off-highway system with huge CO2 savings, massive CO2 saving potential with electrified machines, with autonomous machines. And that's kind of, if you're not in the space, you probably haven't heard that Volvo are doing this, right? It's very best kept secret.
A little bit, but I think we also, and that's interesting for me as well, that we now even get requests from customers that are not naturally in our customer base, that have kind of a repetitive transport needs where they see this could also be applicable. So for us, it's also interesting that's also why we communicate this and want to show people that it's possible, but we need to do it together. It for sure will take some time. It will also initially cost some money. But this is the future we believe in, and that's where we want to go. And then it's also for us great to see and to get the feedback that the market interest is there from the customer base we have today, but also from many others, which is for sure also for us interesting to get into new markets. And you always learn from new things. Yeah.
So Uwe, personally, are you also getting involved then in the other autonomous solutions, or are you just personally kind of involved in commercialization on the mining side, or are you doing everything?
I'm currently the one really that goes to the customer, reviews the sites, discusses with the customers how could a solution look like, that really has the first customer contact, and then my main part is to really connect the customer with our development teams and secure that we develop the things that really solve our customers' problems. Okay. So I used to say that I'm now the technical guy within the commercial team that really tries to bridge customer needs over commercials towards our development guys, so to say.
And could that be any site, so an airport or a quarry, or would it only be kind of the quarries and off-highway stuff?
Theoretically, that could be whatever. I have visited quite different customers the last 4 months, I would say, that have transported kind of very different materials.
Right. Okay. Interesting. I know I'm not going to push you on that because I know you're not. You won't be able to tell me exactly the details on that. But no, really, really interesting, fascinating stuff. So that's been I've learned absolutely loads just from that quick conversation that we've had there. We're kind of basically running up to time now. So thanks again for taking the time out to talk to us today. What I'll do for people who've listened to the show who are interested, we'll put some links to some of the Volvo resources into the show notes so people can connect and find those things. But yeah, thank you very much, Uwe, for coming to talk to us today.
Thanks for the invite. It's been a pleasure.
Okay, great. Thank you. I really, really hope you enjoyed today's episode. If you found that useful, if you found it helpful, please remember, subscribe to the channel, leave us a comment and a rating, or hit like, depending on which platform you are listening to us on. Don't forget as well, we take listeners' questions. We will try and answer them and produce episodes based on those. If you think you've got an interesting story as well and you're involved in the electrification world, we can talk to you and do a podcast episode about that as well. So thanks again for taking the time to listen to us today, and I look forward to talking to you again soon.